Good morning, everyone. Welcome back for the second part of 10.3. Let's continue. So the first question we've got here, example 2, asks us, it gives us a number of information. First off being that AD is 25. We've got a point of tangency right here, which of course means it forms a 90-degree angle. And we've got an equilateral triangle here, which means in this little triangle here, all of the sides are equal and all of the angles are equal. I'm going to flip over to the next slide so we can look at the answers. The first question is, what is the length of the diameter BD? Well, the diameter is right here, all the way through, okay? They gave us 7 and they gave us 25, and we knew that this is a 90-degree angle, so we're going to have to use the Pythagorean theorem to solve this question, okay? It's a pretty good hint that usually if they are asking you for a side length in these questions, almost all of the time they're wanting you to use the Pythagorean theorem. So we do that, we go through, we get the diameter of this triangle is 24 millimeters, okay? The next question is, what's the length of chord BE? Well, BE is right here. We can see at first glance that BC, which is the radius, is 12 because that's half of 24. And then we know that this triangle is an equilateral triangle because all of the sides are equal. So if this guy here is 12, then BE must be 12 as well. The third question is, what is the measure of inscribed angle BED? Now this one takes a few steps, okay? So inside, as I mentioned earlier, inside an equilateral triangle, all of the angles are equal and all of the sides are equal. So if you have 180 degrees that you have to split evenly between 3 angles, 180 divided by 3 is 60. So all 3 of these angles are 60 degrees. So we can put a 60 down right here. That means that this angle right here, the central angle, has got to be 120 because the two of them together have to add up to 180. So this guy here is 120 degrees. Now we realize, hopefully, that we've got an an isosceles triangle. Right here, the side length, and right here, those are equal. So if we have an isosceles triangle with 2 equal side lengths, that means that 2 base angles are equal. So I go 180 minus the 120 we already used is 60. I divide that 60 so I can spread it evenly between the 2 angles. 60 divided by 2 is 30. So the answer there is 30. Again, that one's a little tricky. Here is an example for you to try that is just like the last one, just with some different numbers. So please pause now and give it a try. Let's look at the answers. The first answer is that, what is the length of diameter QR? Well, QR is right here. This is a 90-degree angle, so we've got to use the Pythagorean theorem, just like the last one. We solve the Pythagorean theorem, we get that QR is 40 millimeters, okay? If QR is 40 millimeters, so we then have to add, we are asked, what is the length of chord QS? Well, QS is right here, which is equal to the radius, as this is an equilateral triangle. So if QC is 20, that means that QS is 20 as well. So the answers are 40 and 20. All right, that brings us to the end of our 10.3 assignment. There are some textbook questions I'd like you to try. Not too many. Page 399, numbers 3 to 8 and 14. 14 is a little bit tricky, but let's see if you can figure it out. If you have any questions, please leave them in the comments or send me an email. Thank you.